name is An Jiang,
My name is Chen Sen.
and our project is automatic music transcription for monophonic piano music via image recognition. So in this project, we try to tackle the problem of automatic music transcription using a new approach that transforms the music note detection problem into an image recognition problem using convolutional neural networks. We used an image recognition algorithm from TensorFlow to build and train a CNN that can differentiate and label the corresponding piano note from the spectrums. So we only used the recordings of a single isolated note from the MIDI-aligned piano sounds database. And as the illustration shown in the PowerPoint, we pre-processed the MIDI file and the music track into spectrograms, and that's after the constant Q transform. And those 32 by 32 thumbnails of images are directly fed into CNN architecture.
Our initial training model applies from the paper of our reference, which was originally used to solve the CIFAR10 problem. It consists of two CNN layers with two fully connected layers with ReLU activation function, followed by a 128-way softmax output. The blue box is the convolutional layer processing data only for its receptive field and a reduced number of parameters to learn. The following pooling layer combines the output of neuron clusters at one layer into a single neuron into the next layer. The norm layer is a special layer introduced in the paper to aid generalization and reduce overfit. Initially, we train our model with two layers architecture, but later on we find we can achieve similar accuracy with just one layer and it trains faster. We'll cover details about it in later slides.
So after conducting several experiments on the CNN model and the algorithm in general, excuse me, we have found that by extending the image size to a larger resolution, the model can would have the best accuracy up to 82%. And having a simplified CNN model does not affect the performance too much. And we have a set of examples of input and output here. This is the original track. This is the output generated by the model.
One key finding is that when we remove the original algorithm's image compressing process, the overall training accuracy increased by 5%. We believe the reason behind this is that the original model processing real-world complex objects like cats and dogs, which don't lose too much information after compression. However, our inputs are spectrograms. They really look like each other, so compressing them will lose a lot of information. Based on this observation, we later on simplified our model architecture to only use one layer of CNN and one layer of local ReLU. The new model achieves similar results of the original model and it takes less time to train.
And for future steps, we definitely think that there are room for improvement for our current model. And we can even modify our CNN structure further to further improve our accuracy. And the final question would be how to tackle polyphonic music transcription. We thought that we could simply separate the tracks into monophonic music through ICA or some other methods, and then try to apply the same CNN network that we generated. So here are the references that we use throughout the project, and that will be all. Thank you.
Thank you.